All right, getting into the book again, lesson 1.2.4. I don't know if you guys have noticed, this is actually the last lesson in the chapter, right? What patterns can I find? Got a huge multiplication chart here, missing the tens. Tens are easy. You could fill that in if you wanted to. Don't write in your book though, right? The actual homework is, again, the review and preview part. And I'm going to start doing our homework assignments in a math folder. Some of you might already be doing that. I think that's a good spot to do it. Okay. And the very first part of every homework assignment, you want to develop that habit. Okay. Write your first and last name. Right? Jill student. Write the date. Wow, Thursday, October 8th already. And we can't wait to start writing 2021 instead of 2020. Again, type your math teacher's name and the period, and you can put PER if you want, right? Right. You can also put that little thing there, little circle means period. And then what are we doing here? All right, very first question, right, says use your multiplication table to figure out the missing number in each of the following number sentences. Each missing number is represented by an n. So this is 15 parentheses n equals 225. 15 parentheses n equals 225. I'm writing that down. 1-85 a, and then I'm doing that half parentheses, right? We're using letters now, right? This exact problem has letters, right? Using variables. So make sure you're doing that so we don't include that a as part of the problem. Now, what does 15 parentheses n mean? If you're one of those kids saying 15 times n, you were correct, right? So this is 15 times n. If 15 times n equals 225, then I'm saying 15 times what equals 225? Okay, I could use a fact family, right? And say if 15 times this is 225, then this divided by 15 should be what I'm missing, right? And that's kind of what they're saying for you to do. They said to use your multiplication chart. I don't have one of those big ones. If you're on the ebook, you should have access to it. But if I turn to page 39 in your book, I can find the 15 and zoom in for you a little bit. I could find the 15 and look for a 225, and well, it's way there on the end. So 15 times 15 is the 225. So n must equal 15 on this one, right? So I'm writing n equals 15 on this first one. I'm putting a little box around my answer and a bigger box around the entire problem. Going to the next one. Okay, B. Now this question, sorry, got to go back to it. 84 over 12 equals n. Now, that is a fraction, and every fraction is a division problem. I'm going 84 divided by 12 equals n, right? And again, I can go back to my multiplication chart. I can look at the 12s. Okay, and I can go across till I find an 84, and boom, there it is. Go up, it's a 7. So 84 times 7. I'm sorry, 84 divided by 12 equals 7. 12 times 7 equals 84. So I'm going to write n equals 7 on that one. And they told you to go ahead and use this chart, so don't feel bad if that's what you're doing. Otherwise, you have to sort of learn how to solve algebraic equations is what this is. You didn't know you're doing that. C, 11 parentheses n equals 143. So I'm going to go to my multiplication chart and look at the 11 and follow it till I get to 143, and that will be my answer for n. Okay, actually not going to do that. I'm going to let you do that one. Okay, I want you to give it your best shot, and you try to do as much as you can without my help, and only come back here when you're totally stuck and you have to have some help. Okay, 183 divided by n, 182 divided by n, 182 over n equals 13. So you're going to find your multiplication chart. What are you going to do? Look at the 13s, go all the way over till you find a 182, and whatever is perpendicular with that, the other number, is going to be the n. You try that. 186, what are we doing here? Okay, it says Jack has 4 tiles and wants to find how many shapes he can make with them. Okay, sketch all the arrangements that Jack could make with his tiles, and all the tiles have them touch at least one other tile completely along a side. So no like corners touching, right? Assume that no tiles can overlap. How many arrangements are there? You missed out with your distance learning on an assignment we called toothpicks and tiles. The tiles that people got were these Post-its, and you actually had toothpicks that could be the sides of the tiles. Okay, so I could have my 4 tiles be all in a row like that. That's one way. I can have them be like that, 3 on going up and 1 to the right. I can also have that 1 be on the left. I can have a 1 be on the top. That's Mr. Daniel's favorite because it's the one that looks like a number, 7. I can have it be on the right. I can have it be on the bottom. I can have it be on the left side. Okay? Now, I can also have 3 going like this. You have 1 in the middle on the top, 1 on the bottom, 1 on this side, 1 on this side, right? I have a lot of different choices here. Okay? And they want you to draw those. And then they want you to say, the question is, how many arrangements could you draw? Right? How many different ones? And for each diagram, find the area in tiles and the perimeter, the toothpicks. Or the perimeter, remember what that is, the distance around. So if I start here and I go all around this shape, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? The perimeter of that is 10. Okay? What would the perimeter of this be? 1, 2, 3, 4, 5, 6, 7, 8. What would the perimeter of this be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You get the picture? All right, that's what you're doing on these. Some of these, I mean, will that be any different for the perimeter as this? Right? No, it won't, huh? Okay. And here's will the area ever change on these? The area, that's 4, right? I got 4 squares. How about that? I still have 4 squares. What's the area of that? 4 squares. What's the area of that? Right? So the area is going to stay the same, but the perimeter will change sometimes. You're going to do that and draw some pictures. On the next one, you have to write 4 different fractions that are equal to 1. 4 different fractions that are equal to 1. Well, a lot of you are pretty good at these basic fractions and know that you can write 4 quarters is $1. 4 over 4 equals 1, right? How about 60 minutes out of 60 minutes is 1 hour? How about 100 pennies over 100 pennies is $1, right? How much of a day is 24 hours? 24 hours over 24 hours is 1 day. Okay. And there are infinite other possibilities. Try not to use the 4 that I used. Try to make up your own. Okay. Be creative. Challenge yourself. The next question, 1-88. They have multiples of 2 and 3. I know they wrote the words. I'm just going to write the number and have that be my first one. What's the next multiple of 2? 4. What's after 4? 6. And again, you're like skip counting, but this is 2 multiplied by 1, 2 multiplied by 2, 2 multiplied by 3, right? And let's see how far they go. Okay, they had 3 and 6. So I already have one that's the same, huh? Right? In fact, they sort of had it like this, 3 and then the 6 right there. Let's do that. What's going to be after 6? 9. All right. Okay. And you will continue. They want you to write the rest of the numbers in this row, the rest of the numbers in this row. And then they ask you, what is the smallest number that appears in both rows? And they already gave you that one, right? It's that 6. Okay. That number is said to be the least common multiple of 2 and 3. Find 3 more common multiples of 2 and 3. So you're looking for more. I'm going to let you finish that one. I think you guys could do that. This next one's kind of fun. How many hands long is your bed? Okay, I can't help you with this one. You got to estimate, and then you got to go measure. 1, 2, 3, 4, right? And so on, right? And see how close you were. Okay. Now they want you to first you estimate, and then you go actually measure it and let us know. Okay. And we'll talk about that a little bit on Friday. The next one, they have a fraction, right? 1-90, and they're saying it's a blank over 4. And, right, they got a box, and whatever that is over 4. And on A, you're supposed to come up with a number that could fit in that box that equals 1. Now, I would like when you do this to write the fraction each time. Put your answer up there, but then you look at this and you get smarter every time you look at it, right? Write the answer each time. So this is going to be blank over 4, and on B, they want it to be greater than 1. Greater than sign, right? Okay, remember, it always points at the smaller number. C, something over 4 that is less than 1. D, something over 4 that equals 0. Sorry, that's E. No, that is D. I got it right. All right, good. Don't have to cross it out like I did up there. E, you want to have something over 4 that's greater than, that's bigger than 100. Is that even possible? I think it is, right? So I'm not going to do this one for you. I'm going to let you guess on that one. You can come back and check afterwards. Okay. See if you can figure out a number over 4 that's bigger than 1. A number over 4 that's small. I'm going to let you try these. I think you can do this. Okay? And 1-91, let's go ahead and move it over. 1-91, what we're doing there is you're looking at these patterns. And the first figure 1 looks kind of like that. And then figure 2 looks like the first one, but then it has another dot on top and another dot on the bottom. Figure 3 looks like figure 2, but it's going up, another dot on top, another dot on the bottom. And one of the things they're asking is, how many dots will the 50th figure have? Now, we can see this pattern and figure out, right? Figure 1, I'm writing fig. Fig trees are ripe right now, right? They want you to sketch figures 4 and 5, okay? So I'm going to do 4 is going to look just like 3. And then what am I changing? I'm putting another dot at the bottom, another dot on the top. And 5, I'm not going to sketch the whole thing. I'm going to let you finish that. You get the idea. But one of the things you can do on this is turn this into an in and out. Okay, and say this is figure 1, 2, 3, 4, 5, and this is the dots. Remember those in and outs we did? Okay, let's do that and make these the dots. Okay, zoom in a little bit for you. Now, 1 had how many dots? 1, 2, 3, 4. 2 had how many dots? Well, these 4 plus 1 on top, so that's 6. 3 had how many dots? Well, 1, 2, 3, 4, 5, 6, like we had. All right. And then 7, 8. Right? 1, 2, 3, 4, 5, 6, 7, 8. And 4 is going to have 2 more than that. You guys are starting to see this pattern. It's getting bigger by 2. So 5 will have 12. Now, do you want to do 6, 7, 8, 9, 10, all the way up to 99 so we can get 100? That's tough. So what you want to do is challenge yourself and say, is there a way I can figure out what goes out when X goes in? Okay, and what you're doing is saying, what do I do to the 5 to make it 12? What do I do to the 4 to make it 10? What do I do to 3? Okay, you notice it's going up by 2. So you're thinking, is there a times 2 in there? Let me see. 1 times 2 would be 2. 2 times 2 is going to be 4. 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10. Man, we're close, huh? How much is 12 and 10 apart? 2, huh? How much is 10 and 8 apart? Think about that, and I'll give you the answer on the end. Okay? But don't just wait for the answer. I want you to see if you can figure it out. You might put some more in here, draw some more dots, because if we figure this out, that 100th is going to be easy. Okay? Now, last set of problems are prime factorization problems. And you remember how to get prime factorization. First, what you do is you make a factor tree. So 24, you can start it with 6 times 4. Someone else may have started it 3 times 8. Someone may have said, you know what, that's just 2 times 12. Right? What do you do with the 6? Well, what goes into 6? 6 and 1, but no 1s are allowed. Remember, no 1s are allowed. 3 and 2, 3 times 2. What do you do with the 4? 2 times 2. Whoops. You were going to help me fix that, huh? One of those has to be a 3. Now, nothing goes into 2 except for 2 and 1. So I circle it. Same thing with the 3. I'm circling all these because they're special numbers. What are they called again? Good, prime numbers. I circled a 3. I'm not circling an 8 because I can do 2 times 4. I will circle the 2. And the 4 becomes 2 2s. Okay, I'm going to circle that 2. Now, you don't have to do 3 different ways for 24. I just wanted to show you something. All right, I circled the 3. Now, once you've made your factor tree and all the numbers at the bottom are circled, the prime factorization, you have to have the factor tree and then put those in order from least to greatest. So I have 2, 3, 2, 2, 2 times 2 times 2 times 3. The 3 is going to go last. And the reason I did this 3 different ways, because you could start with 6 and 4, 3 and 8, or 2 and 12, but it doesn't matter how you start, you end up with the same answer. And remember, if you can write some of these as exponents, this is 2 times 2 times 2, that's 2 times itself this many times, so that's 2 to the 3rd power times 3. All right, you go try the last couple, 52 and 105, and check back for the other video for your answers. Okay?